Stat 101 Examples Class 11, Example 4, Linear Regression Test of the Slope. Our example is crawling age. A recent study produced some interesting data about a possible link between when babies start crawling in weeks and the temperature when the babies first try to crawl in degrees Fahrenheit. We've got the table there of temperature and crawling age. First thing to decide which is our x variable and which is the y. Which one are we going to use to predict from the other? The predictor will be on the x and the one that we are predicting will be on the y. So in the question it tells us to link between when babies start crawling and the temperature when they first try to crawl. So we will put temperature on the x-axis and age in weeks on the y. So we'll be using the temperature to predict the crawling age of the baby. So x will be temperature, y will be crawling age. And our general equation for linear regression, you remember, y hat is beta naught plus beta 1 times x. First thing we need to do is look at the data. We would draw a scatter plot as we've done before, remembering to put temperature on the x and the crawling age on the y. Having a look to see if the relationship does in fact look linear. If it doesn't, then we shouldn't be doing linear regression. And if the relationship is linear, which direction is the slope? Drawing a line through the points, we can see there is a negative slope. So when the temperature increases, the crawling age decreases. So as x gets bigger, y gets smaller, a negative gradient on a line through those points. So as when the temperature increases, the crawling age decreases. The points don't all lie on the line, but it's a good enough fit for us to use a linear model. And from our earlier examples, we can use Excel to do the linear regression. We'll go into Excel, and remember we will need to go in to make sure data analysis is there. So data analysis, and we will pick regression. Highlighting the Y range first, that's the crawling age, followed by the X range, the temperature, and choosing a suitable output range, Excel will give us the regression. This is the summary output we have seen before. From this, we're able to get the equation of the least squares regression model. Our general equation, y hat, is beta naught plus beta 1 times x, where beta naught is our intercept and beta 1 is our gradient. Excel calls x variable 1. Picking those two coefficients from the bottom left-hand side of the table. So writing it in context of our example, temperature is beta naught. Crawling age is beta naught, Y is our crawling age. So crawling age is beta naught. That's our intercept coefficient, which is 35.678. And we've got a negative slope, remember, so it'll be negative beta 1, which is our 0.0777. So negative 0.0777 times our x variable, which in this case is our temperature. So we have the equation of our line, which we can now use for prediction. If we know any value of temperature, we can use this equation to find the corresponding crawling age. So our example asks us to use this to predict a crawling age for a baby when the temperature is 40 degrees Fahrenheit. So substituting 40 degrees Fahrenheit into our equation that we've just found, the crawling age at 40 degrees Fahrenheit would be 35.678 minus 0.0777 times that temperature times the 40. And this works out to be 32.57. So if the temperature was 40 degrees, the model would predict the crawling age of our baby at 32.57 weeks. So with our least squares regression model, using any value of temperature, we can predict what the appropriate crawling age would be. In this case, temperature of 40 degrees, the model predicts the crawling age 32.57 weeks. Remember not to use the model for prediction far outside the range of the data that we have. Remember, interpolation, not extrapolation. Next, we want to do the test for the slope. We want to carry out a test using alpha 0.05 to determine whether there's evidence of a significant relationship between the age when babies start crawling and the temperature when they first try to crawl. Using our usual test template, this will be a test of slope. Remember, it's the slope parameter, so it's beta 1 we are testing, the slope beta 1. Our null hypothesis is there no relationship between the temperature and the age they start crawling, so our slope, our beta 1, would equal 0. So no relationship between the two. Our alternate hypothesis is that there will be a relationship, so our slope will be anything but 0. Beta 1 not equal to 0 suggests there is a relationship between the temperature and the crawling age. Our alpha value, remember, 0.05. Degrees of freedom found by using n minus 2. N minus 2 in this case is 10. Our test statistic we will get from Excel. But first of all, let's have a look and see what critical value we will be testing this test statistic against. So it'll be a two-tailed test. The alternate hypothesis gives us two tails, so our 0.05 will be split between the two tails, 0.025 in each end. So we can use Excel as we've done before, the TINV function. 0.05, remember the T function needs two-tailed, 0.05, and it's 10 degrees of freedom. So that value from Excel, 2.228. So we'll have positive 2.228 at one end and negative 2.228 at the other. And those are the critical values we'll be testing our test statistic against. The test statistic, just having a look at our Excel output again, we'll be getting our test statistic for the slope, remember. So the test statistic will be negative 3.097. Remember, it's for beta 1, it's for the slope. Remember to pick up the right test statistic in this case. So our test statistic, negative 3.097 from our Excel output. Our decision, our test statistic, is in the critical region, in the rejection region. So it's further than the negative 2.228, our critical value. So our decision would be to reject the null hypothesis, as negative 3.097 is less than negative 2.2. And the conclusion, in context of the problem, we have sufficient evidence of a significant relationship between the age babies start crawling and the temperature. there's a negative relationship between the two, we have sufficient evidence of a significant relationship between the age the baby starts crawling and the temperature when the baby first starts to crawl. Always putting that conclusion in the context of the particular problem. Does the confidence interval support our decision? If we have a look at the confidence interval from our Excel output, once again, confidence interval for the slope, remember. Make sure we're picking up the correct one from the output. The confidence interval goes from negative 0.134 to negative 0.022. So our confidence interval, negative 0.134 to negative 0.02. Our confidence interval is completely negative. 0 is not included in our interval. So once again, this gives us evidence to support our decision from our test. 0 not contained in our confidence interval, so this supports our decision from our test of slope solution that we did earlier. Confidence interval completely negative, 0 not included in that interval. What other statistics in the Excel output give evidence of the strength of the model for the relationship between the two variables? What information does each give? Taking a look at the Excel output again, we're looking at the correlation and the coefficient of determination. If we look at the correlation first, Excel calls that multiple R. Our correlation coefficient, 0.699, 0.7 to 1 decimal place. Correlation coefficient shows moderate but negative relationship between the two. Remember to pick up the sign of the correlation from the equation of our least squares line. Negative correlation, the strength 0.7, moderate. So it's negative moderate correlation between the two. Moving on to R squared, our coefficient of determination, 0.49. So this means 49% of the variation in the crawling age can be explained using the temperature. Correlation was 0.7, negative 0.7, R squared 0.49. 49% of the variation in the crawling age can be explained using the temperature, or can be explained using our model, if you like. We can also look at the p-value for the f-test, which is the same as our t-test for the slope. So we can pick up our f-test statistic there, or look at the p-value associated with the f-test statistic. The p-value is low, the null must go. Our p-value is small. So once again, further evidence to support our test of the slope. This would also lead to the rejection of the null hypothesis. So various places on the Excel output that we can get evidence to support our decision to reject the null hypothesis. And that's the end of our example 4 on crawling age.